Hello. In this lecture, we continue with the School of Public Health data, and our objective is to plot the coefficients, essentially to create bar plots on top of each other of the estimated coefficients for different methods. That's our objective. So we can compare our results. Okay. Let's say we want to also include a comparison with the forward-backward method together. Okay, so we take that. Okay. Just to refresh your memory, we read the data, we remove the missing values, we do a linear fit. Everything is not a number because the number of observations is less than the number of predictors. Then we perform lasso. Oh, we haven't removed the y's? Why is that? Anyone? Okay, 71. So I don't know what happened. It looks okay. Okay. So this is the summary of the forward and backward method. Now, let's see how we can extract the coefficients. Okay, here it is. Okay, so we are only getting the coefficients let's see, we are only getting the coefficients for which the estimate is non-zero. So we have to store this in another vector, which most of it is 0, and the rest non-zero ones are the estimated coefficients. So that's something we need to do, which is essentially we need the beta hat. We need something like beta hat. Okay, and let's see, beta hat ElNet. Please, you can't do this. Okay, so that's something I will do next time. This time, let's just ignore this. Let's just try to plot the elastic net ridge and lasso estimates on top of each other. So what we do is we use this code. We don't have any errors here. And then we have also bridge, right? No error bars. Lasso, elastic net, ridge. Okay. Let's say elastic net on top. Then lasso, then ridge. Okay, so this is very interesting because this is again, this is not a perfect graph. It needs a title here. This should say elastic net. This should say lasso. This should say ridge. And we don't need these three features. Actually, only one of them is sufficient because it's just a repetition. It's a distraction. So these two should be removed. And yeah, I mean, values, okay, replace that with coefficients. But the major things is that elastic net, lasso, ridge, remove the two features. Okay. Now, another thing that would be nice is to color code these. So the ones that are positive, you can color them as blue, and the ones that are negative as red. All right, but that's a secondary thing, so don't spend too much time on it. But here we can see that ElasticNet and Lasso are very similar, and Ridge is so all these predictors here are more or less clamped to 0, and except for these few, and there's not a big grouping effect happening. Because there's a very small difference between ElasticNet and Ridge. Okay. Now we want to order this in such a way that the largest value from the largest to the smallest based on the coefficients of ElasticNet. Okay, start a new session. Hope this happens. Oh, I didn't want to run this. So nothing happens. I want to run this one. Okay, beautiful. So you see there are a couple of problems. Yes, obviously if you have too many features, there's not really much you can do here. And we can play a little bit with the font size to make this smaller. And there are ways like if these have, if each feature is a has a word name, then you can try to plot them vertically and have a small font. But if you have many features, this is something we can't do anything about, but it's still helpful in terms of pattern. And I mean, there's a little bit of a grouping effect going on here. Lasso mainly picks these three. These two are more prominent, but it's hard really to see. There's not a big grouping effect happening. The negatives pretty much match. Overall it matches, except that here we have these fluctuations up and down, up and down, up and down, which Lasso and ElasticNet essentially are telling us that these just cancel each other out, so just clamp them to 0. Okay, so this is very interesting. And again, if I wanted to revise this figure, I would never make a presentation with this figure. I would find a way to make this more visible, or make them smaller, or another thing that could be done is just to show the labels associated with these, with the few vital coefficients. So you can have like 1, 2, 3, 4, 5, 6, 7 labels here, and find a smart way of adding the title of the labels, and then the rest, because they're 0, we don't care, and then you do the same thing here. So you only present the labels of the coefficients of the vital few predictors. Okay, that's one thing. Address this. That's the first thing I would do. Second, I would remove this feature here, I would leave this. Or we could also remove it, because once these have labels, then we don't need the feature here. I would add elastic net lasso ridge. And last thing is that I would also make the scale the same. So if this goes up to 0.5 or 0.6, and at the bottom it goes to negative 0.4, I would make the scale of all of them, let's say from negative 0.4 or negative 0.5 to positive 0.6, negative 0.5 to positive 0.6, negative 0.5 to positive 0.6. So the scales, the sizes, the scales would be in a way that it is meaningful to compare the size of the coefficients. Okay, because here these fluctuations look large compared to here, but if we look at the scale, we see that this scale is this one unit is 0.4, where these are all smaller than 0.1. So that's what I would do. And lastly, another thing that is meaningless to do is to plot the standardized coefficients. The coefficients that are standardized, because the different predictors have different scales, so the relative size of the estimated coefficients may more be a reflection of the scale of the predictors, as opposed to the importance or strong association with the response. Finally, I might also add another column here, which would include the intercept. Or I would just, under the label, I would say intercept is 6 point whatever, intercept equal this, intercept equal that. Okay. These are a couple of things that we will do in the next lecture. We will also add the stepwise result and the backward-forward result. So we have a fully integrated code that analyzes, plots, presents everything in the same graph in a really nice way.